NBS involve conserving, rehabilitating natural ecosystem, or the enhancement or creation of natural processes modify artificial ecosystem. We will see some example. If you have a sedimentation trap and a nutrient trap in by vegetables, this is a sort of a mixed NBS. You can have it to micro, for example, dry soil, macro, landscape scales. So there are many different. And the important thing is that this has been taking a lot of momentum in the last 25 years, because the use, of course, a natural-based solution cannot replace a dam. Let's be frank. You have things that, or a pipe of bringing water to someone. You cannot use a natural-based solution to bring water to a house, okay, if you need to do it in that way, or to replace a dam. But there are ways to do dams. You will see an example with the site of Professor Cicero in the Guadiana River Basin. You will see some action that can be portrayed. But now, the important thing is that ecohydrology has been using natural-based solution in the last 3 decades or so. And after this report came out, and ecohydrology, all the group gave a great contribution to this report, suddenly, in the last 6-7 years, ecohydrology is on, and ecosystem services and water ecosystems and ecohydrology are on the mouth of everybody. Everybody speaks about that. So it's a good momentum. Why? Because we said, natural-based solution, and we've been using that. You remember when we went to Perugia to discuss, with all these agencies say ecohydrology is an important part of that. Yeah, but ecohydrology, what you do something. No, it's so we managed to convince. We're not convinced. No, not everybody is convinced, but it's taking a pace little by little. Okay, so ecosystems have been recognized also by different targets in the goals. We will see in another occasion. Okay, so NBS work with nature instead of against. Okay, so you don't do an NBS, a nature-based solution for water, like a dam to trap the water. No environmental flow, no nothing, eutrophication, biodiversity loss. No, these are there to okay, systems are scaled in a different way, but okay, statement in blue. Show particular promise in achieving progress towards sustainable food production, improve human settlements, access to water supply and sanitation services, water-related disaster risk reduction. They can also help to respond to the impacts of climate change and water resources. Johannes de Ribu, who is your compatriot, will come and will make a presentation on the site in Acela and Buriquito, and you will see how food production is done in this particular case. Okay, we're talking a small case, but many small pilot cases can make up a big picture. Okay, now. Imagine the ideal world. This is like a nirvana of ecohydrology in which NBS are used at all scales. You have a diagram. They are used to conserving and protecting water resources in protected areas, growing crops as a cross-slope to reduce erosion and increase infiltration, and so on and so forth. You get to downstream. You get to the sea, and you use purification system, wetlands, and so on and so forth. Okay, so there are some ideas on that relies on the use of NBS, but it would be ideal to take a basin, a water basin, a river basin, and act in that way. But it's not as easy as it seems to be said. Okay. Okay, now I will skip that and leave it to you. Role of ecosystem restored in the water cycle. Water availability, okay? You use NBS for water availability. There are many examples in that report for water availability. For urban, for example, I thought we were going to see one of the examples of the sponge cities.
Tuesday.
Yes.
Tuesday.
Yes, we are going.
On Tuesday.
You've been, or
No, we are going on Tuesday.
Tuesday.
Next Tuesday.
Next week, yes.
So this is an important fact. You know that the government of China has invested a lot of money in this one city. We visited one some years ago in Xi'an, and very impressive place because they use roof gardens, they use constructed wetlands, they use porous walkways, and everything is conceived and designed to trap rainwater, to reuse the water, the wastewater concept that is ideal. Okay. We talk about the funds involved in that because one should be extremely. This is the example on the right of response city I was used. We will go Tuesday and we will learn more on that. Okay, so water availability, and then you have example for water quality. Water quality, for example, check at this second point. Okay, non-point diffuse source pollution. What do you think about non-point source pollution? Is a pipe that goes up with wastewater. Non-point is linear. You have agricultural field, okay, that goes to a river. You have a lot of nutrients were used as fertilizer. This flows with the rain, it infiltrates the groundwater, and they affect the river. Okay, so non-point diffuse source pollution, increased water availability. You've seen we'll see later on maybe an example with one of the sites in Poland. You use ecotones, buffer zones to trap the nutrients. You know that this kind of plant, you can cut it and replant it. You can use it later on. You can re-establish the cycle of nutrients, mostly nitrogen and phosphorus. Anyway, reduce nutrient runoff, infiltration from water. There are many examples in the demonstration site in Ecohydrology. So water quality again. Water-related risk, because you can use wetlands for flood control. It's done also in this one city, so you can use for that reason. Okay, risk, security, of course. Now. I said it again, what is ecotourism? Integrative science, interaction between hydrology and biota, and using natural processes to reinforce ecosystem services. I think it's worth to repeat it all the time. I think it once in the head will come. Okay, it's also an applied science that is solution-oriented science. It explains things, but not only explains and describe. It is used to make solutions that are applied in the field. Okay, so you address climate, soil, vegetation, groundwater interactions, riparian runoff, flooding, flow regime dynamics, fluvial groundwater inputs to lake reservoirs, estuary, everything. Okay, and okay, we said in the WBSRC we also have the interaction between green and grey infrastructure. And our impacts in this era also affect GDS at a large rate, influencing those processes that originate ecosystem service. Now, what I'm trying to do is since sometimes is relate GDS to ecohydrology. Now, I don't have many examples. I have some examples to explain, but there is further to investigate, and this is what I'm trying to do in the future, and to get more consistent on that. But try to relate these two things and see how does it work. Okay. For example, there's an example of a site in Poland. Is a demonstration site of the Ecohydrology, where they have constructed effective buffer zones. They are denitrification wall by geochemical barriers in this Sulejo reservoir in Poland, an area characterized by cyanobacterial blooms due to heavy pollution of groundwater with nitrates and phosphorus from non-point source pollution, the agricultural one. This was a reservoir that was constructed in the 70s for water supply, and became more and more eutrophic because of the nutrients coming into the water, not only as a flow, superficial flow, but also on groundwater. So the Polish colleagues tried to design and construct this barrier, and it's very intelligent the way they did it, and they managed to phosphate and nitrate concentration in groundwater was reduced by 58% and 85% respectively. So it's good result that must be increased. So you have an example here. This is a denitrification wall. Practically, there are big boxes, so you excavated 2-3 meters trenches, parallel, you see here, parallel to the lake, okay? And then you put these cages, which are full of limestones, rocks of limestone, pieces of limestone. The intelligence said that you cover, the water are coming here, okay? You have filtrates, you have a buffer zone, also plant buffer zone later, but these cages, once every sometimes, you pick it up with a crane, you burn the limestone, so you re-clean it and you put it back. So it's a continuous process. Okay, costs money, implies technology, but this is a good way to reduce. This is a GDE because we have groundwater that is filling up a reservoir. So this is one of the examples. If the GDE is polluted by nutrients, that would be a way how to use it. This is case of nitrates, okay, and NO3. Here, phosphate, PO4, and they do it with also limestone, but also with vinyl sawdust and mixed with soil. And again, this one they pick it up again in cages. Maybe we will see it in the presentation of Professor Zalewski, all the processes they use. I mean, it's not that you go and you do it and it implies a lot of work, but very efficient. Now, the other way.
Sorry, Giuseppe.
Yes.
So you install these trenches at
the transition zone.
A transition zone.
You see what the water is here.
Yes.
Here, the water is here. Okay, you see plants here.
Yeah.
These are the buffer zone plants. Just upland you do these branches. But this is demonstration site. That to prove that this concentration are trapped, and the results of the quality of water after that. Okay, so we're talking about groundwater. The deep groundwater you cannot be polluted. Okay, you have, in some cases you use bacteria to depollute groundwater deep, but it's a lot of techniques because you have to inject water in anyway. This is for surface shallow related to GDEs, okay, to groundwater dependent ecosystem. This lake is in part also dependent from ecosystem. Is a manufactured reservoir by humans, but also in part. So I'm working on finding examples, but they're not easy because nobody never applied that. So it's new frontiers. And for example, this example is again in Poland. This we've been seen many times. The sequential stormwater purification biofiltration system reduced the concentration of total nitrogen and phosphorus up to 60%. What they do is stormwater, urban stormwater, they collect it, and they put it in this sequential purification biofiltration. So you have a sedimentation zone, you have a geochemical barrier enhanced by geotextile curtains, you have a biofiltration zone with plants, and then the water goes in this Teresa reservoir. And these Teresa reservoirs, yes, with good water quality. And for example, they re-established tourism in this area because before nobody was going. It was smelling, eutrophication, bad. Now they have beaches, the people go during the summer, of course, because Poland is very cold during the winter. And also this acted as a percolation reservoir and goes to supply the groundwater. Okay, so this is a system, a combined system. In a way, it's sequential. So is hydro technology gray, but not very gray, but because you have to use some gray material. But it's a natural-based solution. They're using different methodologies to have water that then infiltrates in the aquifer, in downgraded. Okay. Now I want to. That's the last thing, and then we finish. We spoke about MAR techniques, managing aquifer recharge. There are many different techniques in this. The one we saw was divine filtration. Okay, so like you put a well, there's a river, 50 meters, sandy loamy, you pump from here, you get water from the river, which is dirty, and cleans up. Okay, but MAR technique can be an important way to think about it, how we can interact on impacted groundwater dependent ecosystems, okay? Because you will see. So MAR techniques have been applied for millennia to manage available water resources. We'll see an example in Ecuador. There has been an example on the demonstration site, the one, the video that you were seeing before in Spain. Methodology ranging complexity from simple rainwater harvesting to deep well injection of reclaimed water into saline aquifer. Methodology applied should be appropriate to meet the defined objective. Of course, what you need to store water, clean water. Okay, clogging. You know what clogging is? Clogging is, for example, in a well, you have sand going in and clogs the well. You cannot use it anymore. Or in the reservoirs, sedimentation is so big that there's no longer space for water. But anyway, this is one of the, but we're not talking about that. Okay, matrix is spreading methods. Okay, this is very, very simple. You have where you have unconfined aquifers, so this is the table water of the aquifer. Okay, 3, and you use superficial reservoir for temporary storage of water, infiltration pond, like the one we saw in Angkor. Okay, so it goes to the aquifer and replenishes the aquifer. Of course, you need permeable material. If this is impermeable, end of the story, it doesn't go through, So it filters and it goes up.
But the filtration pore sizes will be determined by you. The pore sizes for the filtration medium.
It depends on the thickness of the substrate that you put,
Okay.
And the velocity of it depends. If you're in a very arid area where it rains not much, you need to speed up the infiltration because otherwise the evaporation brings all the water away. If you're talking about, so it depends a little bit by the. There's a manual. There have been 2 manuals done by MAR group of UNESCO. They are the best. But there are 2 publications. I'm not sure. I can send it to you. For example, this one, percolation pond, in-channel modification. This is an example of patas. Okay. Mark explained. Did you talk about the borradas and all this? Okay. You put small dams in the river to reduce the velocity first, and then to increase the percolation. Okay, the water that goes down. And that's the case of the example of patas also, because here, downgrading, they have wells and they pump the water and we launch it to the sea. So, this also has an important function because we establish the hydrological cycle. Imagine that with the humidity mixed up with the atmosphere, it creates biodiversity, there are plants, and the cycle is real. So it's extremely important. And this is techniques that is managing aquifers, which are technique, but it's very close to what ecohydrology concept is. Right? Okay, that's an example. Or you have a sand dams. Okay, sand dams here on the right. These are particular in arid zones. You have sands here, and you go up with the dam by the sides as soon as it fills up. And then you use the well to withdraw the water which is stored in that sand reservoir. And subsurface dam recharge release. There are countries that are using. You have water coming in an aquifer and losing to the sea. They said, why do we lose all this? And we put pumps, but it costs a lot of money. We put a dam, the water collects. And then by gravity we use it, or by slightly pumping. Here, I have an example because I had the great opportunity to be in this place. This is Pacific, This is Japan, this is China, Korea, Taiwan. This is an island which belongs to mainland Japan. It's called Miyakojima, south of Okinawa, closer to Taiwan. And this is, you see, this is the place. From north to south, rocks are inclining this way, and it's carbonatic rock. So there's a big aquifer that loses everything here on the sea. So the Japanese said, wow, we use these dams. So look at that. They constructed a dam. Now this is a part of the dam, okay? You see it here. And then they have a reservoir, and they use it in the way they want it. So this is a MAR technique, you know, it's called subsurface dam or recharge release, if you have recharge, not in this case. And then another one, induced back filtration, the one we used in Vietnam. So you can do it in rivers. There are examples in Egypt, there are in many countries. You can see a lot of examples where you use the river water instead to use water treatment plants that are costly and in terms of installation, maintenance, cost a lot of money. You use the river, you pump water from the river, you have a certain distance, you do your investigation, everything, and you filter the water and you have good water quality to be used. Okay, this implies a little bit more techniques, but sometimes wells are not so expensive nowadays, okay? Or dune filtration, this is always, it's very natural, for example. You have at different levels water that by gradient goes down and it refills the lower gradient small reservoir electrodes. Okay, and then rainwater harvesting, you can do it in your home if you have it. Depends on the quality of water. It needs a system. You can have just a small reservoir here that can be used if you have a little garden, or also for, I don't know, toilet flushing if you don't want to use good quality water. Or sometimes you also have an underground reservoir and a well, but anyway, this can be done at bigger infrastructure. So building this, what you use in Spawn City, that I think that we will see there. So with this I conclude.